Hello students, in this lecture we are going to discuss application of straight line which we have learned in the previous 3 classes in the physics. So there are various topics of physics where we can apply the properties of straight line, that like equation of straight line or the slope of straight line, which we have learned earlier. Now in the previous lecture we have given a question to you to solve you on the basis of what we have learned in the previous 3 lectures. So the question was, there are 3 points whose coordinates were given. One point is 2, k, minus 3, 1 and 5, 2. On the basis of a fact that these 3 are collinear points, we have to calculate the value of given quantity k here. Now, using the coordinates of these 2 points, I can easily write the equation of a straight line. If you remember, the one form of a straight line was y minus y1 is equal to y1 minus y2 upon x1 minus x2 into x minus x1. So this is one of the form where coordinate of 2 points is given. Now let us say this is our point number 1 and this is our point number 2. So this represents x1, this is y1, this is x2 and this is y2. So let us put the values of all these numbers. The equation will be y minus 1 is equal to 1 minus 2 divided by minus 3 minus 5 into x minus, it is minus 3, so it is x plus 3 here. So this is the equation of the straight line. I can write this as minus 1 upon minus 8, so it is 1 upon 8 into x plus 3 here. So I can write the equation as 8y minus 8 is equal to x plus 3, or 8y minus x is equal to plus 11. Let us say this is our equation number 1 here. So now using this equation I have to calculate the value of this quantity k. Now since these 3 are collinear points, so this point also lie on this straight line. So we can put the value of coordinates of this point and this will satisfy equation number 1 here. So let us put the value. So k is y here, so it is 8k minus x is 2 minus 2, it is equal to 11. So I can write k as 13 upon 8. So using this principle of equation of straight line, you can easily solve such question. You must already have tried this question and you may have got the correct answer. In case your answer was not matching with this answer, you can just retry the question so that you can learn the concept in a more smoother ways. Now, in this lecture, we are going to discuss where we can apply the whatever we have learned about straight line in various parts of physics here. So, now let us first start with the very basic concept of displacement and velocity. You all have heard this concept of displacement and velocity, and you know that velocity is rate of change of displacement in a given case. Now, if I have been given a graph between x versus t, can I calculate velocity? Or if I have been given a graph between velocity versus time, can I calculate the value of acceleration in a given case? Now let us say a graph is given here. On the y-axis, I am representing displacement as x. On the x-axis, I am representing time. Now there are various type of graph can be possible. One graph is this, let us say. The second graph, again it is x versus t graph, and the second graph is like this. Then again there is a third graph, x versus t again. This is like this. And fourth graph is like this, x versus t. So what can we say about the velocity in this case? So now you can say that the starting point is at some distance x naught from the origin. After that, the particle is going along this line. Now, as Subbu sir told you in the previous lecture, that this angle theta, if we can calculate theta, then tan theta will give us slope of the straight line. And as we have learned in differentiation or application of differentiation, you know that slope in this case will give us velocity or rate of change of displacement. So just by knowing the value of theta, we can calculate the slope. Slope will give us velocity. And since this angle is an acute angle from positive side of x-axis, tan theta will be positive, and this says that the velocity is positive, and you can see that this angle is constant throughout along the line. So the velocity is positive and it is constant. Similarly, suppose I will explain you the value of velocity in this case and in this case.
Okay. So basically, as sir has already told us that the slope here is actually representing the rate of change of displacement with respect to time. So which gives you the velocity. Now you can see this link here and you can understand more easily what we are talking about. If you have not seen that particular lecture, the link is here. Just go and see that link. So here we have the velocity. If we want to find the slope of this line, so this angle theta, which is an obtuse angle, and we know that for obtuse angle, tan theta will become negative. So the slope tan theta will be negative. In such situation, if we talk about the velocity, so this velocity is a negative velocity over here. This is not a positive velocity, it is a negative value. That is, the rate of change of displacement with time is negative, which actually means that if the time increases, there is a decrease in displacement. So the direction is opposite. Am I right, sir?
Yeah. You can see that when the time is increasing along this line, the position that is x is continuously decreasing. At this point, x becomes 0, and after that again become negative value. So the continuously with respect to time, the position is decreasing, and that is being represented by negative value of the velocity. Again, the value of velocity is constant. The magnitude is remain constant because theta is constant at all points along a straight line, but the value is negative, that is displacement is continuously decreasing here.
No. So the direction is basically opposite to the displacement.
Yeah, displacement is decreasing. If you are going along x-axis, the velocity is tending to make this point to come towards origin.
So can I say that if you are going in the opposite direction from me, then you are having a positive velocity, and if you are coming in this direction,
the displacement is increasing. When the two persons are going against each other, then the displacement is increasing. We can say that velocity of one with respect to other is positive. When the two persons are coming towards each other, it means with respect to them, the displacement is continuously decreasing. And that decrease in displacement can be seen here by the direction of velocity, which is negative. Similarly, similar question was given to you in the previous question, in which the axis is parallel to this axis. In this case, what is the velocity of this particle? So Subbu sir will tell you.
Yeah. So this is again a line which is parallel to x-axis. That means its slope is 0. And if its slope is 0, velocity is also 0. That is the rate of change of displacement with time, which is actually velocity, is tan theta, which is coming out to be 0.
This simply represents that the particle is at rest, and hence the position of the particle with time is not changing here. Now, in this case, this graph is not a straight line, but the application of the straight line is there. Again, you have learned the concept of velocity with respect to displacement, and you can see the link here that is given, which we have already discussed in previous lectures. So you can see here that at any point, if I draw a tangent, so this slope of tangent at any point represents velocity. You can again see that, let us say this angle is alpha. Then alpha again is a acute angle, so the velocity at this point is positive. But if I move at some other point, again I can see that the slope at this point is again positive, but the slope is different from the previous one. And hence we can say that, let us say the angle is beta. Again, if I come to this point, the angle will be different, and continuously you can see that the angle is increasing, and hence the velocity is increasing. So these three graphs are example of uniform motion, and this graph is example of non-uniform motion. All these things we can simply understand using the principle of straight line, which we have learned in the previous lectures.
So further, if I try to understand, this is a graph which is convex downward.
Yeah.
This is a convex downward graph, and in such situation we are seeing that the tangent slope is actually increasing. That is, beta is greater than alpha.
At some other point, and it will again increase.
Will again increase. Tan beta is also greater than tan alpha. So the velocity at this point A is actually greater than the velocity at the point B.
So non-uniform motion with increasing velocity, and a similar type of question I am going to give you, which you have to calculate how the velocity is changing in another case, and the graph of that situation is not exactly same but similar to what we have learned here. So here you have to give us answer in the comment that whether in this case the motion is uniform or non-uniform, and if non-uniform, whether the velocity is increasing or decreasing as the time is increasing. So this you have to give in the comment section. You can answer this, and we will discuss this again in the next lecture. So for this lecture, thank you for the patience of the students, and we are very much sure that you have learned some very interesting concept which will help you in understanding various topics of physics. Thank you, students.
Thank you.